Brining is treating food with brine or coarse salt, one which preserves and seasons the food while enhancing tenderness. Flavor can be further developed with additions such as herbs, spices, sugar, caramel, or vinegar. Meat and fish are typically brined for less than 24 hours, while vegetables, cheeses, and fruit are brined in a much longer process known as pickling. Brining is similar to marination, except that a marinade usually includes a significant amount of acid, such as vinegar or citrus juice. Brining is also similar to curing, which usually involves significantly drying the food, and is done over a much longer time period. Meat. Brining is a food processing technique in which meat is soaked in a salt water solution, a brine, similar to marination before cooking. The brine may be seasoned with spices and herbs. Duration varies from 30 minutes to several days depending on the cut size, thickness, and desired effect. Dry brining. Brining can also be achieved by covering the meat in dry coarse salt and left to rest for several hours. The salt draws moisture from the interior of the meat to the surface, where it mixes with the salt and is then reabsorbed with the salt, essentially brining the meat in its own juices. The salt rub is then rinsed off and discarded before cooking. Food scientists have two theories about the brining effect, but which one is correct is still under debate. The brine surrounding the cells has a higher concentration of salt than the fluid within the cells, but the cell fluid has a higher concentration of other solutes. This leads salt ions to diffuse into the cell, while the solutes in the cells cannot diffuse through the cell membranes into the brine. The increased salinity of the cell fluid causes the cell to absorb water from the brine via osmosis. The salt introduced into the cell denatures its proteins. The proteins coagulate, forming a matrix that traps water molecules and holds them during cooking. This prevents the meat from dehydrating. Fish. As opposed to dry salting, fish brining or wet salting is performed by immersion of fish into brine, or just sprinkling it with salt without draining the moisture. To ensure long-term preservation, the solution has to contain at least 20% of salt, a process called heavy salting in fisheries. Heavy salted fish must be desalted in cold water or milk before consumption. If less salt is used, the fish is suited for immediate consumption, but additional refrigeration is necessary for longer preservation. Wet salting is used for preparation of salted herring, non-gutted, with hard or soft roe, and heavily salted, 20% NaCl brine, with final product containing around 12% salt. Soused herring, which is gutted and lightly salted, 2 to 3% NaCl, without roe. Anchovies, which can be immersed in brine or wet salted. After several years, the fish liquefies and can be processed into paste or anchovy butter, caviar, and other types of roe. Vegetables are immersed in brine, vinegar, or vinaigrette for extended periods of time in the process of pickling, where they undergo anaerobic fermentation which affects their texture and flavor. Pickling can preserve perishable foods for months. Antimicrobial herbs and spices, such as mustard seed, garlic, cinnamon, or cloves, are often added. Unlike the canning process, pickling, which includes fermentation, does not require that the food be completely sterile before it is sealed. The acidity or salinity of the solution, the temperature of fermentation, and the exclusion of oxygen determine which microorganisms dominate, and determine the flavor of the end product. Cheese. Brine is used in two ways in cheese production. Brined cheeses, such as halloumi and feta, are pickled in brine. Washed rind cheeses, such as Munster, are washed with brine during the production process. Brining is the process of infusing proteins with salt, sugar, and other flavorings via the process of osmosis. Osmosis, as you might remember from science class, has something to do with molecules passing back and forth through a membrane until there are equal concentrations on each side. Brining is the process of infusing proteins with salt, sugar, and flavor. In addition, it tenderizes and moisturizes meat. Typically, the protein is soaked in a solution of water, or another liquid such as apple juice, beer, or wine, salt and spices for a number of hours in the refrigerator. Brining has been used for thousands of years to preserve meats and fish without refrigeration. Corned beef and lox are two good examples. Today, of course, we have refrigeration, and the main reason we brine is for improved flavor and texture. The simplest brine is salt and water. Here's a little lesson on how brining works. Brine is far saltier than any type of protein. When you soak the protein in the brine, by the laws of osmosis, the salt wants to travel into the protein until the salt concentration in the protein and in the brine are equal to one another. Osmosis applies to other particles like sugar, which will do the same thing. The benefit of extreme brining: packing proteins in pure dry salt or in a solution of salt water that has the absolute maximum amount of salt that water can physically hold, called a supersaturated salt solution, is preserving food. When the salt goes in, water comes out, and meats with very little water do not rot, which is why jerky comes in a bag on the shelf and not in the refrigerated case of the grocery store. The benefit of what we'll call gentle brining is transferring salt and other flavors into the meat itself and adding moisture. The moisture part is a bit counterintuitive because preserving the meat means less moisture. Yes, but we're talking about the gentle brining, where the salt that infuses the meat unravels and collapses some of the protein, allowing more water into the meat in addition to the salt. A wet brine is exactly what it sounds like: a solution of salt, sugar, spices, and other flavorings. It's the brine most people use for turkey. Wet brining can be used for any meat or fish with a few adjustments to the salt concentration and the time the protein is in the brine. Corned beef is a great example of a meat that is wet brined in barrels. Dry brining is when meat is heavily salted and then left to sit for some time. The salted meat is put on a rack in a very shallow pan such as a half-sheet pan so the air can circulate around it. The meat can be left this way for hours or days, depending on the meat and the recipe. One common example of this method is the gravlax making process. Salmon is completely covered in a dry salt-sugar herb mix and left to cure in the fridge. After 2 or 3 days, you brush away the cure and it's ready to serve. Brine, or briny water, is a high-concentration solution of salt, typically sodium chloride or calcium chloride, in water. In diverse contexts, brine may refer to the salt solutions ranging from about 3.5%, a typical concentration of seawater, on the lower end of that of solutions used for brining foods, up to about 26%, a typical saturated solution, depending on temperature. Brine forms naturally due to evaporation of ground saline water, but it is also generated in the mining of sodium chloride. One brine is used for food processing and cooking, pickling and brining, for de-icing of roads and other structures, and in a number of technological processes. It is also a byproduct of many industrial processes, such as desalination, so it requires wastewater treatment for proper disposal or further utilization, fresh water recovery. In nature, brines are produced in multiple ways in nature. Modification of seawater via evaporation results in the concentration of salts in the residual fluid. A characteristic geologic deposit called an evaporite is formed as different dissolved ions reach the saturation states of minerals, typically gypsum and halite. Dissolution of such salt deposits into water can produce brines as well. As seawater freezes, dissolved ions tend to remain in solution, resulting in a fluid termed a cryogenic brine. At the time of formation, these cryogenic brines are by definition cooler than the freezing temperature of seawater and can produce a feature called a brinicle, where cool brines descend, freezing the surrounding seawater. The brine cropping out at the surface as saltwater springs are known as licks or salines. 3. The contents of dissolved solids in groundwater vary highly from one location to another on Earth, both in terms of specific constituents, e.g. halite, anhydrite, carbonates, gypsum, fluoride salts, organic halides, and sulfate salts, and regarding the concentration level. Using one of several classification of groundwater based on total dissolved solids, TDS, brine is water containing more than 100,000 mg/LTDS. Brine is commonly produced during well completion operations, particularly after the hydraulic fracturing of a well. Uses: iodine and bromine mining. Iodine, essential for human health, is obtained on a commercial scale from iodide-rich brines. The purification begins by converting iodide to hydroiodic acid, which is then oxidized to iodine using chlorine. The iodine is then separated by evaporation or adsorption. Bromine is also obtained from brines. Akin to the production of iodine, the process exploits the easy oxidation of bromide into bromine, again using chlorine as the oxidant. The product bromine can be selectively collected by exploiting its volatility. Lithium and magnesium mining. Major deposits of lithium are in the form of brines. Magnesium is also produced in part from waste brine from various sources, such as potash production. Crude magnesium oxides and chlorides mixtures are converted into magnesium metal by electrolysis. Chlorine production. Elemental chlorine can be produced by electrolysis of brine, NaCl solution. This process also produces sodium hydroxide, NaOH, and hydrogen gas, H2. Refrigerating fluid. Brine, primarily cheap brines based on calcium chloride and sodium chloride 9, is used as a secondary fluid in large refrigeration installations to transport thermal energy. It is used because the addition of salt to water lowers the freezing temperature of the solution, significantly enhancing its heat transport efficiency at low cost. The lowest freezing point obtainable for NaCl brine, called its eutectic point, is 21.1 degrees C, 6.0 degree F, at the concentration of 23.3% NaCl by weight. Because of their corrosive properties, salt-based brines have been replaced by organic liquids such as ethylene glycol. Sodium chloride brine spray is used on some fishing vessels to freeze fish. The brine temperature is generally 5 degree F, 21 degree C. Air blast freezing temperatures are 31 degree F, 35 degree C, or lower. Given the higher temperature of brine, the system efficiency over air blast freezing can be higher. High-value fish usually are frozen at much lower temperatures, below the practical temperature limit for brine. Water softening and purification. Brine is used for regeneration of ion exchange resins. After treatment, ion exchange resin beads saturated with calcium and magnesium ions from the treated water, are regenerated by soaking in brine containing 6 to 12% NaCl. The sodium ions from brine replace the calcium and magnesium ions on the beads. Culinary. Brine is a common agent in food processing and cooking. Brining is used to preserve or season the food. Brining can be applied to vegetables, cheeses, fruit, and some fish in a process known as pickling. Meat and fish are typically steeped in brine for shorter periods of time, as a form of marination, enhancing its tenderness and flavor, or to enhance shelf period. De-icing. In lower temperatures, a brine solution can be used to de-ice or reduce freezing temperatures on roads. Quenching. Quenching is a heat treatment process when forging metals such as steel. A brine solution, along with oil and other substances, is commonly used to harden steel. When brine is used, there is an enhanced uniformity of the cooling process and heat transfer. The desalination process consists of the separation of salts from an aqueous solution to obtain fresh water from a source of seawater or brackish water, and in turn, a discharge is generated, commonly called brine. Characteristics. The characteristics of the discharge depend on different factors, such as the desalination technology used, salinity and quality of the water used, environmental and oceanographic characteristics, desalination process carried out, among others. The discharge of desalination plants by seawater reverse osmosis, SWRO, are mainly characterized by presenting a salinity concentration that can, in the worst case, double the salinity of the seawater used, and unlike of thermal desalination plants, have practically the same temperature and dissolved oxygen as the seawater used. Dissolved chemicals. The discharge could contain trace chemical products used during the industrial treatment supplies such as antiscalants, coagulants, flocculants which are discarded together with the discharge, and which could affect the physical chemical quality of the effluent. However, these are practically consumed during the process and the concentrations in the discharge are very low, which are practically diluted during the discharge, without affecting marine ecosystems. Heavy metals. The materials used in SWRO plants are dominated by nonmetallic components and stainless steels, since lower operating temperatures allow the construction of desalination plants with more corrosion-resistant coatings. Therefore, the concentration values of heavy metals in the discharge of SWRO plants are much lower than the acute toxicity levels to generate environmental impacts on marine ecosystems. Discharge. The discharge is generally dumped back into the sea, through an underwater outfall or coastal release, due to its lower energy and economic cost compared to other discharge methods. Due to its increase in salinity, the discharge has a greater density compared to the surrounding seawater. Therefore, when the discharge reaches the sea, it can form a saline plume that tends to follow the bathymetric line of the bottom until it is completely diluted. The distribution of the salt plume may depend on different factors, such as the production capacity of the plant, the discharge method, the oceanographic and environmental conditions of the discharge point, among others. Marine environment. Brine discharge might lead to an increase in salinity above certain threshold levels that has the potential to affect benthic communities, especially those more sensitive to osmotic pressure, finally having an effect on their abundance and diversity. However, if appropriate mitigation measures are applied, the potential environmental impacts of discharges from SWRO plants can be correctly minimized. Some examples can be found in countries such as Spain, Israel, Chile, or Australia, in which the mitigation measures adopted reduce the area affected by the discharge, guaranteeing a sustainable development of the desalination process without significant impacts on marine ecosystems. When noticeable effects have been detected on the environment surrounding discharge areas, it generally corresponds to old desalination plants in which the correct mitigation measures were not implemented. Some examples can be found in Spain, Australia, or Chile, where it has been shown that saline plumes do not exceed values of 5% with respect to the natural salinity of the sea in a radius less than 100 m from the point of discharge when proper measures are adopted. Mitigation measures. The mitigation measures that are typically employed to prevent negatively impacting sensitive marine environments are listed below. A well-designed discharge mechanism, employing the use of efficient diffusers or pre-dilution of discharges with seawater. An environmental evaluation study, which assesses the correct location of the discharge point, considering geomorphological and oceanographic variables, such as currents, bathymetry, and type of bottom, which favor a rapid mixing process of the discharges. The implementation of an adequate environmental surveillance program, which guarantees the correct operation of the desalination plants during their operational phase, allowing an accurate and early diagnostics of potential environmental threats. Regulation. Currently, in many countries, such as Spain, Israel, Chile, and Australia, the development of a rigorous environmental impact assessment process is required, both for the construction and operational phases. During its development, the most important legal management tools are established within the local environmental regulation, to prevent and adopt mitigation measures that guarantee the sustainable development of desalination projects. This includes a series of administrative tools and periodic environmental monitoring, to adopt preventive, corrective, and further monitoring measures of the state of the surrounding marine environment. Under the context of this environmental assessment process, numerous countries require compliance with an environmental monitoring program, PVA, in order to evaluate the effectiveness of the preventive and corrective measures established during the environmental assessment process, and thus guarantee the operation of desalination plants without producing significant environmental impacts. The PVAs establishes a series of mandatory requirements that are mainly related to the monitoring of discharge, using a series of measurements and characterizations based on physical, chemical, and biological information. In addition, The PVAs could also include different requirements related to monitoring the effects of seawater intake and those that may potentially be related to effects on the terrestrial environment. Wastewater. Brine is a byproduct of many industrial processes, such as desalination, power plant cooling towers, produced water from oil and natural gas extraction, acid mine or acid rock drainage, reverse osmosis reject, chloralkali wastewater treatment, pulp and paper mill effluent, and waste streams from food and beverage processing. Along with diluted salts, it can contain residues of pretreatment and cleaning chemicals, their reaction byproducts and heavy metals due to corrosion. Wastewater brine can pose a significant environmental hazard, both due to corrosive and sediment-forming effects of salts and toxicity of other chemicals diluted in it. Unpolluted brine from desalination plants and cooling towers can be returned to the ocean. From the desalination process, reject brine is produced, which proposes potential damages to the marine life and habitats. To limit the environmental impact, it can be diluted with another stream of water, such as the outfall of a wastewater treatment or power plant. Since brine is heavier than seawater and would accumulate on the ocean bottom, it requires methods to ensure proper diffusion, such as installing underwater diffusers in the sewerage. Other methods include drying in evaporation ponds, injecting to deep wells, and storing and reusing the brine for irrigation, de-icing, or dust control purposes. Technologies for treatment of polluted brine include membrane filtration processes, such as reverse osmosis and forward osmosis, ion exchange processes such as electrodialysis or weak acid cation exchange, or evaporation processes, such as thermal brine concentrators and crystallizers employing mechanical vapor recompression and steam. New methods for membrane brine concentration, employing osmotically assisted reverse osmosis and related processes, are beginning to gain ground as part of zero liquid discharge systems, ZLD. Composition and purification. Brine consists of concentrated solution of Na+ and Cl ions. Other cations found in various brines include K+, Mg2+, Ca2+, and Senior2+. The latter three are problematic because they form scale and they react with soaps. Aside from chloride, brines sometimes contain Br and I and, most problematically, sulfate SO2. 4 purification steps often include the addition of calcium oxide to precipitate solid magnesium hydroxide together with gypsum, CaSO4, which can be removed by filtration. Further purification is achieved by fractional crystallization. The resulting purified salt is called evaporated salt or vacuum salt. Thank you for watching this video.